So my name's Chris Carrigan. I was actually registered for this session, and then Chrissy asked me if I could chair it, which is fine by me because I want to learn as much as you, hopefully. I'm the data advisor to a patient movement called Use My Data. It's the only independent patient movement of patients, relatives, and carers in the UK, which is focused on the use of patient data to save lives and improve outcomes. We've had a real interest in OMOP ourselves. In fact, I'm in the process of setting up an OMOP session for our members. My background is in and around health data for about 30 odd years, including most recently I was based up at University of Leeds with the Leeds Teaching Hospital Trust. We're also looking at starting to do some work using OMOP. So again, very topical to me. We'll go to the session. I'm going to introduce Quin in a second, but one question which I'd just ask you if you could respond to is anybody actually using OMOP now? If you could press the raise hand button, I could get some idea about how many people are actually using OMOP or have come across it in their working lives. 1, 2. I can see 2 hands, 3 hands. I hope Chris is keeping account. So small number. Okay. Quin, now you know what you're going at. That doesn't surprise me. I think from my perspective, OMOP is one of these new up-and-coming things, and I'm here to learn as much as you, which is why it's really good to have Quin here. So Quin, she can tell you details about what she does in a second, but she's based up at the, University of, Lancashire Teaching Hospitals, beg your pardon, Quin, putting you in the wrong place. She's a data scientist and lead OMOP analytics engineer there. And she's been leading the OMOP transformation work up there, looking through the data set. So real practical experience that I think we can all learn from. Been doing this for a few years now. So Quin, shall I let you start talking and you can use your slides? If people could ask questions through the chat, we'll pick them up towards the end of Quin's session and we'll then pick up some of the questions and go through those on block. Okay, Quin.
Great. So can everyone see the slides if they come up okay?
Yeah.
Great. So as Chris says, I'm Quin Ashcroft. I'm a data scientist and I'm leading the OMOP transformation at Lancashire Teaching Hospitals. I've been at the Trust for over 8 years now, but particularly in this area for the last 2. And we've had our OMOP instance up and running now for almost a year to the month nearly. So today I'm going to be talking through OMOP as a concept and then how we've achieved our instance at the Trust. So first off is our team. We are really lovely represented through some icons. We're led by Vishnu Chandrabalan. He's our head of data science. He's also leading the LSCSD programme and he's also a consultant surgeon at the Trust. It's me in the middle, already been introduced, and it's also Tim Howcroft, who is a clinical scientist. So first off really is our Trust background and our data challenges. So the Trust manages 2 big hospitals. We have Royal Preston Hospital and Chorley and South River Hospital. There's a wide range of services. There's general medical care, surgery and our emergency departments, but we also have specialised tertiary services such as cancer and neurosurgery. We have a population, well, we serve a population of over 1.5 million people in Lancashire and our surrounding areas. When there's several key IT systems, we've had our main electronic patient record, normally known as an EPR, since 2005, with a big push for clinical documentation from 2017 onwards, which has included our vital signs data, our drugs, core assessments such as ward rounds and admission assessments. Also, our critical care ward is fully paperless now, so everything is electronically documented on there. So there's an awful lot of data being collected around the Trust every minute, 10 minutes. It's so much data being collected. But we also have specialist systems as well, such as our pathology system that holds data that doesn't make it back into the EPR. There's antimicrobial resistance, more complete histology data for tumours. And we also use the Somerset Cancer Registry at the Trust, which holds detailed cancer data, which again is separate from our core EPR. There's numerous smaller specialised systems such as audiology as well. Some of our key challenges is the aforementioned numerous clinical systems that are not linked together, different databases from multiple vendors. There was the need of standardising our Trust data into one place was recognised, so we could participate more in research and that collaboration across trusts. And as part of this, we received funding and are a data partner with Eden and HR UK, and as well as the NIHR for 12 months of the work. So this is trying to condense what OMOP is into a slide or two is quite difficult. So I'm going to give a very brief a high level overview of what OMOP is. So I'll come back to the diagram on the right, but in short, that's an entity relationship diagram. And that is the whole of OMOP described in a diagram. So OMOP stands for the Observational Medical Outcomes Partnership and Common Data Model. And it's been widely adopted standard design, and it's to transform the structure and format of observational health data. The key goal of OMOP is to enable systematic analysis of health records, research databases, by providing that unified structure for data collection and analysis. It can allow researchers, healthcare providers and organisations to use standardised terminology, making data from different sources comparable, interoperable and ready for that large-scale analytics. OMOP was developed by the Observational Health Data Sciences and Informatics Initiative, known as Odyssey, and it was originally created to support being able to compare effectiveness of research in healthcare, and it's since grown into a globally recognised framework. Observational research really relies on real-world health data, which is collected in that routine medical care, mainly on electronic health records and patient registries. Without standardisation, this data is often quite highly siloed and inconsistent across systems. I don't know how many of you work directly with patient data, but in our core patient table, there are 3 different identifiers, which you use depends on what you need. Things like this make it quite difficult to analyse and compare on a large scale, because one day it's NHS number, if you're using a different part of our warehouse, it's patient ID, and then it could be medical record number. That's just one example of one table. OMOP can address these challenges by creating a common data structure that transforms all the data set into that consistent format. A key part of it is data harmonisation. So that conversion of data sets, whether different systems, clinics, countries, it becomes that one standardised format, and it helps with that data aggregation and comparison. For us, by converting local data to the OMOP standard, we can then move our research work across regional and national boundaries. We can collaborate globally if the call came for it. On our research studies, a hospital like in the UK can share and compare those findings with a clinic in America or Japan, for example, using the same model without the need for any data to actually leave the institute that's running the study. It's also that key enabler of observational research, with allowing the real world data into that large scale study. So coming back to the entity relationship diagram, so OMOP organises data into standardised tables. They're made up of clinical tables and fact tables, and these should be consistent across different data sets, and it ensures that data set transformed into OMOP can be analysed with the same methods as mentioned before. Scroll back down, sorry. So the main issue with it is achieving that standardisation. So OMOP enforces consistency by mapping local clinical terminologies like SNOMED, ICD code, RX norm into these standardised vocabularies, and it ensures that the diagnosis, treatment and outcomes are represented consistently, even when different healthcare systems use. And that's how you can get that standardisation across different countries, because it's that key single standardised vocabularies. And then with the interoperability, we can integrate data from our multiple healthcare systems. As I mentioned on the previous slides, we have a lot. So they're all now the majority are into this single instance with those single identifiers and single concepts running through them. So for the benefits of OMOP, for us, we found quite a few, but what are the key benefits, and why, more importantly, did we choose to adopt OMOP as our common data model? So first off is the standardised structure. The data goes into a common format, irrelevant of where it originated from. And by doing this, there's that cross-database integration. We can link our pathology data to our cancer and then background to our EPR, demographic and condition data. There is the added interoperability with the other systems. We're working with Trinitex for clinical trial discovery, and they ingest our anonymised OMOP data into their data model. The standardisations led also to improved data quality. We have reduced duplication, because when you have numerous systems, you have numerous places to record very similar things. There's also a really good community with Odyssey too, a lot of support, and if you need it, there's really good forums, and all the information's open source as well. And I think that's one thing we found, is the community's been key to answering some of the questions we had. So how did we get to our CDM? This is a timeline from start to finish for our first instance, which we did last year. Very quick, we were up and running for the first instance in the 6 months, and that was with data being used and cohorts being identified. So we started in March 23 was our first commit into GitHub, and we had our first final instance in October 23. So really, how did we start? The majority of this work was undertaken in-house without the use of an SME. We did have some support with part of our vocabulary mapping, but otherwise it was fully in-house. Originally, we started with using Python scripts. Quickly realised it was not sustainable because there's just a huge amount of data that was going through our pipeline. And we also wanted to try and achieve daily incremental refreshing as well. So we had a refreshed OMOP instance every morning ready for use. We then identified our key tables in our data warehouse and set up our GitHub repository. So as I just mentioned, we tried it to start with just Python scripts and then realized it works. We wanted to identify a data transformation tool. So we ended up doing the majority of our, all of our transformation using open source software called DBT. So what DBT is, it's an open source tool, and it enables us to transform our raw data into an analytics ready format. And the key concept really of DBT are its SQL-based data transformation. So our learning curve initially was quite slow. My background is a BI analyst. I was a BI analyst at the Trust for 6 years before moving into data science. We used SQL every day, so really familiar with it. I didn't have to learn anything else apart from a little bit of Visual Studio, and that was it. And we already used that as well. So DBT uses SQL scripts to transform that raw data into organized data sets. It also has really good version control and collaboration with it, because these scripts are treated like software code. So it allows version control through GitHub, which is what we used, and it made that collaboration within our team of 3 much easier as well. It's all trackable, testable, and all the data models are reproducible too. Another key aspect of it was it being modular and reusable code. So it made it a lot easier to reuse and build upon our previous transformations. We used a lot of macros, which is a function of DBT in our ETL, and you can pass through variables, meaning you can reuse them multiple times. DBT also has built-in testing, and it auto documents as well. I'll show you a screenshot of that later on. Documentation is not one of my strong points, so the fact that it had it built into it already was really helpful, and it meant that even my minimal documentation ended up being really useful, and it circled around and helped us become better at documenting it too. So the final key thing that really led us towards DBT was the ability to incrementally load our source tables. So one of our patient table, for example, has 2 million patients in it. We didn't want to refresh that every day. It's a complete waste of resource if nothing's changed. So we have a watermarked column, and we can bring in the new patients every day. And that's how the incremental pattern is working. And then that went in hand with aiming for our daily refresh too at the same time. So going into phase 1, we concentrated firstly on our core EPR. So we mapped our core EPR tables first, including drugs and our blood data. And we populated the key OMOP clinical tables as a target along with our person and visit, and I believe it was location for the target lookup tables too. And then alongside that, as part of the OMOP transformation, was our vocabulary mapping to the standardized vocabularies. So our transformation, and it looks briefly, it's quite a blurry diagram, so I'll try and briefly explain over what they are. So we bring all our data in at the source layer. So I don't think you'll be able to see this, but we have like our source flex, which is our EPR, bacteriology is pathology, and then we have SCR2. They get brought into a similar staging area as well, and then they get grouped together. We have a master patient index, and then we add our vocabulary. We have an OMOP'd and our OMOP table, and our era then, which sits above it. So that is really the structure of our entire ETL. It passes through these 6 levels, we're calling them. And our source layer is where the incremental loads happen. And then we feed, depending on the pipeline, we feed like a CDC, which stands for change data capture, through it. And then we end up incrementally refreshing our instance every day. From phase 1, we found some initial challenges. So as I mentioned before, we originally began just with Python and SQL. We had performance issues at the beginning, leads into DBT. But I think the key thing that we found was our vocabulary mapping was really time consuming and really complex. It required a lot of specialist knowledge from technical and clinical input to get that vocabulary mapping right, because there's so many different vocabularies. How do you pick the right one? How do you make sure that the concept is being represented correctly in the standardized vocabulary? So we ended up having some assistance from Chinatex with some of our vocabulary mapping, mainly for bloods data and drugs. They helped us with, and we did the rest. Phase 2, for the initial instance, we then identified some additional data sources. We then incorporated those into our workflow and then repeated the vocabulary mapping to standardized vocabulary, and that became an iterative process. We found another data source and then re-followed through phase 2, phase 3 in a similar fashion. Now, again, we don't pick the background colour for DBT's documentation. It's a really lovely blue, but it makes seeing the models shown quite difficult because the colours just don't work well. So the blue was not our choice. So it is colour coded, but it doesn't always line up very well. So the amber is our source layer. The sort of peachy pink is staging, and then it goes up into another very, very closely coloured pinks. You can't really tell them apart, staging and vocabulary. But this is data lineage just for our person table. So I've took a screenshot of this for the talk, but this is actually interactive. So I can right click onto each of these blocks, and it'll give me the code. It'll tell me the dependencies, and I've documented each of these models. So each block represents a model or a set of SQL code, and then the dependencies are all shown through and linked, as you can see. Really, and that is where we've ended up at the end of this data transformation. We have an OMOP instance refreshing daily. We using our incremental loading, and we've, from the initial set of 6 levels that I showed previously, we also have another 3 layers on top of that, because part of our sustainability was trying to make it not just for research use, because that's what it's designed for, but we have an aim to use it for operational intelligence as well. So we have our production layer, which is what comes off of our daily ETL, and that's what we refer to as bronze. We have some very high level constraints applied to it, some data quality, and we end up with a silver layer, which is our operational layer. So our national data opt-out patients are still in this because it's not for research. We wouldn't take out some of the more minor data quality. And then what we have on top of that is a gold layer. So that is our research layer, and that is the layer that our universities, academics would have access to. And in this, our patients who have opted out are removed before this. It's fully anonymised at this layer as well. And this is fully conformant to OMOP standards. So, and we became fully certified just in this June 2024, and we're listed now as an Eden data partner on the portal, and that's for our gold layer. And we had Promptly Health help us with our sign off for that back in June. Some of the key challenges we've faced, so sustainability, staffing, and suitability. So, I mean, first of all, the sustainability for it financially, it's always the case. We need it's needs sufficient resource. Resourcing it is always going to cost some form of money. We're feeding our data into Chinatech, who are a clinical trials discovery company. And I think the aim is for it to become self-sufficient as part of the SDE programme in the future. The other side is infrastructure. Cloud is where we're heading as a trust, and again, as part of the SDE programme. But that comes with its own challenges. You need different expertise that we don't have, or we have now, but didn't have in-house. Also the technology. DBT didn't cover everything we needed. We want to be able to work in multiple environments, and it was great to start with, but as our needs have got wider, it's just not, we don't know how sustainable it's going to be. So we're testing SQL Mesh instead, in the process of deciding if that's how we want to move down, and then try and use that instead. For staffing as well, it's a very multidisciplinary team that you need. We're lucky that our team is, we're very fortunate, we're led by a consultant surgeon, so he has a lot of clinical background. He's also technically very good as well, so we have both sides. We have Tim, who's a clinical scientist who has a background in genetics and pathology, and then I'm part of the team as well. I've worked with BI for years, so I knew the data really well before we started actually trying to change the data around and get it transformed into this common. So we were the common data model. So we were very fortunate in our setup, and we've had really good executive support as well, which was key. There's also the suitability. So it is an American format. It's not designed for NHS data, but now more NHS trusts are adopting it. There is NHS vocabulary that now exists. It didn't when we first started. So that is changing, and it is getting better. But there are still a lot of challenges out there to make it work in a sustainable way. And finally, for the future of OMOP LTH, we're starting to use our data now for our projects. We are doing some antimicrobial stewardship with Manchester University, which is looking at the appropriate use of antibiotics, switching from oral to IV, and prescribing patterns. We're also worked with Oxford University on drugs prescribing patterns and medical device usage with real world evidence. We're also looking at breast cancer outcomes with Edinburgh for patients in both of our areas. We're also moving to the operational monitoring, which I mentioned before. So we're looking at sepsis patients at the trust and using our OMOP data to feed into our sepsis monitoring, because that data wouldn't have been available before OMOP existed. And again, as part of our Manchester University project, we're looking at antibiotic compliance daily as well as part of that. And that's where the two levels or layers come into it. So all our projects and research are happening on the gold, but our operationals happening on the silver. And then hopefully our future work, we are expanding OMOP and the implementation of that across the region. We've just started with our second trust recently as part of our our regional SDE programme. And then we're looking to bring that into the LSC SDE and make a regional OMOP instance. That is in the future. It's not what's happening now, but the aim is to get there in the future. And then all of that would expand on our research capabilities and, again, the operational intelligence too. So I thought that's all of my slides covered. So thank you for listening. I've put my email address on here if anyone wants to. Feel free to email me. We also are on X, not Twitter, as I keep getting reminded. So if anyone wants to follow on there, you're always welcome to. Thank you.